Hey everyone, today we're going to be looking at this Pentair Ultratemp pool heater that needs a little bit of help. This is a heat pump style pool heater, part number 460932, made in 2011. Electronically, everything seems to be in working order. And while this outer layer has done well to protect the coils from bending and damage, there is a lot of dirt caught in these coils. We could see a lot of green as well on the lower portion of the coil. There must be water filling up inside. No surprise given the amount of detritus that has collected in this unit. We could also see that it has caused rusting on a lot of the metal surfaces, especially the horizontal ones. The fan has excessive vibration, and given the state of the mount, it's no surprise. So we're going to bring this pool heater back into good, efficient working condition. Let's get started. I trace the power right back up to this panel. My panel doesn't have a fuse or a switch, it's a disconnect, so I pull it right out. And I'm going to store this with the other parts away from this panel. I could reinstall it upside down, I simply choose not to. The display is off and there is no more power going to the unit. There are screws along the front, and screws going down, and screws along the bottom panel, as well as the sides. We'll come to find that these screws have wires stuffed in them. There's nothing holding them in, because the pieces behind them have long since deteriorated. So I'm removing this bent wire from each of these holes as I move along. Screws on the side of the unit also require removal. This one on the top cover going through the side. This one came out. This one right here is completely stuck, seized, and rusted in. Has no chance. Another one here. These three along the front will be removed next. This top one was just spinning. There must be no clip in the back. The next two came out without any incident. This one on the bottom just spun, connected to nothing, had to be pulled out. And this one felt like it had a clip behind it, which was a surprise. But that was enough to remove this section of cover, which I put off to the side so it wouldn't get damaged. I immediately saw this and thought it was a crack, but it turns out it was just sealant. So now I gotta drill out this top screw, which is frozen in, using progressively larger bits, starting with this pilot. And I have to make sure it doesn't get too hot because it starts to melt that plastic around it. But eventually that head broke off. The house facing side also has screws. That side seems to be in better condition away from the elements. I used my Torx as that screw actually still exists on this size and is easily removed with no issues. An 11 mil removes the two top acorn nuts, along with the associated washer. Same on the other side. Lifting the top panel allows this second panel to be removed from the unit and set off to a safe place. I'll try not to disturb the folks who live here. This cover will now be removed so that the fan can be disconnected. It's held on by 6 screws and 1 frog. The cover is put off to the side. Humming sounds where the fan or compressor doesn't start are generally attributed to this capacitor. If it's bulging on the bottom, it's ready to go. Costs about $30 to replace, or a service call costs you about $300. Your choice. 4 cables coming in from the fan need to be accounted for: green, yellow, red, black, and brown. Green ties to the central ground. Red connects up here to this relay. Black to position 2 on this relay, and brown to this post on the capacitor. Take pictures. After which all 4 connections can be pulled out. This is the black one being pulled back out of the loom. The brown one off the capacitor. I used pliers for the red one only because I couldn't reach it behind those cables, and then pulled it out as well. That ground will be cut for now and replaced with a new ground once the new motor and fan arrives, so I'll just put this off to the side. All these wires are now disconnected. The end screw holding the conduit will now be loosened and put away in a safe area. Now the conduit and cables can be pulled through, completing this requirement for the top cover removal. Since the two top nuts have already been removed, the top cover could simply be lifted up and then flipped back to remove it from the unit and put to a safe area. We can now get a clear view of the amount of accumulation in this unit, which is pretty bad. I can't see any drain holes in the unit. They're completely covered if there are any, so we're going to have to go and clean this up before we do anything else. Keeping in mind that we do have some friends living in the area. An inspection of the top was worse than I thought. It wasn't just the mount, but also the fan. Large sections completely rusted away. Like the fan mount, it just crumbles in my fingers. The fan blades itself, perfect condition. But look over here where the bearing seal is completely eroded away. It's an accident waiting to happen. So I'll temporarily reinstall this cover to cover the electronics and put in a couple screws. The first thing I want to do is attempt to vacuum out as many leaves and dirt as possible from this unit before I use the hose and get mud everywhere. At this point, even with the vacuuming, we still can't see where any of the drain holes are. All the debris is now removed from the heat exchanger as well as the bottom panel. At least all of the large debris has been removed. Making our way around, we're able to conduct an inspection now. We see some rust on the horizontal surfaces. We'll tend to that as well. Using the hose now and starting with the heat exchanger, we could see that it's able to actually fill up with water because it's so caked up with dirt. So I'm working on this first, slowly clearing the dirt out from this plastic area until it's able to drain properly. As I move the hose away to hit another area, you can see the water will simply stay in there. It's not draining down, or it's draining down extremely slowly. And that is not how this should be functioning. Hitting the areas on the bottom of that pan, as I do this, I still at this point have not found any of the drain holes for this unit. Clearly the water must be draining from somewhere or this would be filling up like a swimming pool. Although it is not draining quickly, it is draining. This process was repeated for quite some time, and while I did have some success eventually clearing out the heat exchanger, the bottom could not be cleared because the leaves and debris would simply stay there. So I decided to add pluggable drains to the unit that could be used during maintenance only and capped once maintenance is completed, putting several of them in the bottom of the pan. That would be easier to service. With that, all of the leaves and dirt could easily travel out of the unit. One final hole also drilled forward in the center, as well as the far end, allowed for everything in this unit to be cleaned out perfectly, not a single leaf or piece of dirt remaining. With that, we could also see the drain holes around here and how incredibly small they are, which is why I couldn't see them, why they get stuffed so easily, and why it's impossible to clean this out once leaves fill up in here. 7/8 nylon plugs will be used to fill the holes because we don't want to keep them open, as it'll lower the efficiency of this unit, drawing air from the bottom instead of through the coils. These can be taken off as needed to perform the maintenance again. This one was open and served no purpose, so I just put a plug here to increase the overall efficiency. This is the only one I'm going to leave open in case all of the drain holes get plugged. It won't fill up and flood, causing the base to continue to rust. The rust is actually something we're going to be dealing with in just a bit. The rusted screw that was drilled out will now have to be removed, starting with penetrating oil. I'll let that soak. And taking my time, I'm eventually able to work it loose without damaging the chassis. The fan will now be separated from the shroud, or what's left of the shroud. They were both rusted together and required a little bit of encouragement to separate. The 90 bend is screwed off from the end of the pipe holding the wires and put to the side. It's saved. And the hose holding all those cables is pulled through the shroud, separating the fan from the shroud. Most of this is rust and very little was supporting the fan, an accident waiting to happen. But if we look at the fan, I don't know how this thing was even still running. Most of this is rusted away as well. You would think this would have been made out of rust-resistant materials. There is still a label on the fan providing some information. And if we look, we see the blades are in like perfect condition, but everything else is just completely rusted away. Depends on the type of metal. They should have made everything out of the same metal as the blades. I initially tried both distilled vinegar and strong peroxide to remove the rust stains from the plastic. Neither of these, an acid nor a base, proved to be effective at removing the rust stains. Trying multiple applications, it didn't do anything. Even soaking it with a towel, it just seemed hopeless. I did find this product called Iron Out, which did a tremendous job at removing the rust stains entirely. It just came out perfect, exactly what I wanted. And we could see it just sprays on like a gel. And just leave it there several hours or overnight and it's gone. So I stacked up all the pieces and prepared them for spraying and just sprayed multiple applications until the rust was gone. Just making sure that I removed the old metal clips beforehand. Now using an 11 mil, I'm going to separate the cover from the shroud, and I do want to be careful because there's some rubber dampeners in between here, and I do not want to break them when I do this. This metal cover is garbage and can be put off to the side. Pieces of the metal cover are embedded in this rubber dampener right here, so I carefully remove them. Our new metal cover has arrived, so we'll carefully remove it from the packaging and put it off to the side. This piece will also be treated with the rust remover, and new speed nuts will be resized against the original old ones. So we'll be going for number 10. All the rust stains have been successfully removed from this top cover. All of the rubber dampeners have been cleaned. It'll now be washed to remove any residual chemicals as well as any dirt and debris. The cover is now perfectly clean. All of the rubber dampeners are aligned so that they point inwards towards the middle in the same direction. The cover is then carefully laid down over the dampeners so that they align properly, making any adjustments as needed. A small amount of Permatex is then placed on a paper towel so that the screws can be lightly coated as well as the washers as a rust inhibitor before all four of them are placed into the cover and secured down by hand, not tightened down with a wrench until all four of them are in there to reduce the chances of cracking. At that point, they would then be carefully snugged down onto the rubber dampeners, altering in a crisscross pattern until a light amount of resistance was felt. This hose holding the wires comes off the old motor and it is retained. Making our way back into the main unit, we'll be using a wire brush to remove any loose rust off of the horizontal surfaces where rust has accumulated in these areas. We could see some of these areas now. This one area was a lost cause and the corner was simply removed. It's not structural, so it's not that important. All the areas to be treated are now sprayed with the Por 15 degreaser, and this is left wet for about 15 minutes, at which point the entire inner unit is completely washed off to remove the degreaser. Once dry, we move to step 2, which is the metal etchant with the brush. All of the areas that are going to be treated receive the etchant, and it is reapplied because it is not allowed to dry over the course of 15 minutes. We can see over there as well, over here where I removed some of that metal around there. And now after 15 minutes, everything again is completely washed out to ensure that the etch is removed. At this time, all the coils are also cleaned from the inside out, especially at the bottom where a lot of the dirt has accumulated. Everything now degreased, etched, dried, and ready for the final stage. The Por 15 is applied in 2 layers. The first layer goes on thin and is allowed to become almost dry before the second layer is then applied. This was a single-use container. It didn't really have a lot, so I wasn't going to paint everything with Por 15 because I probably needed it for other projects as well. So wherever it was rusted in for like 20 years, that's where it got it. That rusted corner was fixed up nice as well. and every surface that had rust is now coated with Por 15 with proper pre-treatment with margins to ensure that the rust is now inhibited from spreading, and this portion of the project is complete. I just need to wait for this coat to dry and apply one more layer. Meanwhile, the top is supported on 2 cardboard boxes so we could do the motor and fan installation from both sides. The motor and acorn kit is from Pentair 473785, and it seems in every way identical to the old motor, with the electrical wires as well as the ground. Anti-seize is added to the threads and the area in the middle that rusted out last time. It's also added to the mating surface on the bottom of the grill. The motor is then installed into the grill such that the cables point in the direction towards the hole in the cover. The 4 supplied acorn nuts are then used to secure the motor into the grill. They are all then snugged down with a 3/8 socket. At this point, all the wires off the motor will be straightened out, taped together and to a rigid wire so that they can be pushed through the hose. Once the rigid wire makes it out the other side, it can be easily pulled through, and the hose is pulled all the way to the end of the motor, at which point it's pressed onto the fitting on the edge of the motor. The wires are then pulled through the hole in the cover one at a time. Then subsequently the hose is pulled through, allowing for a little bit of slack and completing this task. The wires then go through the 90 fitting one at a time. That fitting is then screwed down onto the hose. We've also purchased a new fan. The packing wasn't amazing. Some of the blades arrived bent and needed to be straightened out. The fan would simply lower down on the shaft of the motor like this. There's a flat spot on the shaft where the set screw would tighten down. The old fan was measured to get the approximate distance. I got about 3/4 of an inch. This portion of the shaft was covered with anti-seize in an attempt to stop future rusting. The fan was then lowered into position, measured, and tightened down. The blades is then given a last once over since the packing was less than optimal, making sure everything is straight so there's no excessive vibration. And this portion is complete and ready to be installed. I went away for 3 months and came back to continue this project. All the areas I added the Por 15 looks good. Everything is nice and clean in here, no problems at all. But I'll show you where I put the top cover on for storage purposes. Everything here already started to rust. This looks absolutely nasty. Over here on the ends and the seams, it seems to be really cheap. I thought it would have lasted longer since it's outdoor gear. We can see on the side of the motor also rusting. Not happy with this at all. I'm going to need to do something about it. I'm taking this back out. We get a look under the motor. The same parts that deteriorated last time are already starting to rust. Where I put the anti-seize seemed to be unaffected, but the rest of the motor started to oxidize on the rear cover. I sanded the grill to remove the rust, and I'm going to apply Por 15 to everything to stop this. The bottom, top, and between the welds was coated with Por 15. We're also going to stand off the motor with number 8 washers for proper drainage. The motor standing off on washers, its case, top, bottom, and sides now coated in Por 15. Meeting up here at the shaft, which I've removed all of this rust, and I'm coating the entire shaft with anti-seize because the shaft was starting to rust too. I'm wondering if any of the equipment that I purchased is outdoor rated. But this should do it. This is now my modified outdoor rated setup for my pool equipment. I have a set of weather resistant clips that are going to be used for the rebuild. I'll install the first one now. One on the far side as well. Both of these studs are coated with anti-seize. The cover and fan assembly is carefully lowered into position, then lifted up so the cable harness can be pulled under, and then drop back down. The studs of the assembly are carefully negotiated through the top holes. Anti-seize is applied to the threads before the washer as well as the acorn nut are placed back on the stud. Same thing on the other side. After which both sides will gently be snugged down with a 7/16 socket. With that, the top cover, fan, and motor is now fully secured to the unit. We can now proceed on with the wiring back into this box. And that starts with bringing all the wires through the hole. And then the cap through the other side so it can be screwed down on that 90 bracket. Then gently snugging it down with a pair of pliers. This ground will be loosened first from the top and bottom to remove that green wire that I cut, replacing it with the green wire that came with the new motor. And now we can see that new green wire is installed. We'll now install these three using the pictures that I had from before as a reference. I'll plug the first wire into here is the black wire. The second one in the capacitor right here in the back is the brown wire. And the third wire is red going under here as shown. Everything is now all wired up and we're ready to do a quick smoke test. So I reintroduced my pull-out switch. And there's a certain amount of time it takes to sense the water temperature, but things are looking good. And as we hit 0, we're ready to start testing. It shows the pool at 76, it's set for 89. We're just going to run it for a couple of minutes for a smoke test. So I'm going to hit on now. You can see the on light turned on and the fan started spinning. And it'll stay like this for 5 minutes before the compressor kicks in. Everything sounds good, no vibration, no excessive noise. The blades look relatively balanced, I don't see any wobble. The compressor will kick on in 5 seconds. Everything sounds good from the compressor, I don't hear any strange noises, nothing that concerns me. It will not, however, cool properly with this cover open, though I do feel the change in temperature on these pipes is a good sign. Also on the heat exchanger, it is starting to get hot, though it will always run inefficient until it's closed up. Most of this air is going to pull from the path of least resistance when that front cover is open. So now we'll begin the final reassembly and the evaluation of the performance of the unit, closing up this electrical box first. This is one of the few metal fasteners to actually be left intact. I'll remove it now and replace it with a new one, as well as all of the ones that had deteriorated and were gone. Now we could see that they've all been replaced, even here on the side. And on the actual covers themselves are also several, so I'll be installing this first cover now. Lining it up until the holes match, I'll install my first screw and just give it a couple of turns so it's able to support this side of the cover. And then once I get that second screw in up top, it'll be held enough that I could turn that screw all the way in and then come back and tighten that first screw and start the rest of this installation, tightening down all the screws, not too tight, but just snug so it doesn't vibrate. This clip installed earlier takes a larger screw, we'll do that last. But now this cover is completely installed, ready for the next cover, which also has a clip on it. We'll install that one now around that front panel. Fits in nicely, and we'll start installing the screws. Working to keep everything aligned as I do so. Some go through 2 layers of plastic, some go through 1, some into those clips. Some along the side in the center actually go through the metal frame of the unit itself. Here's one of the bigger screws along the inner side. Here's one along the bottom by the power. And here's one that goes through to the frame. The second one through the frame. And now our final screw. All of our new clips and stainless steel screws are installed on the cover, holding everything together. Now power is reapplied, and we'll be running now for performance. So we'll start it up. Now it's correctly pulling air through with the front cover closed. 2 hours later, we're already up 2 degrees. We'll be back monitoring. The timer did shut off the pool pump, so it's worth checking out. The pool heater did stop functioning from a water flow sensor, so that is definitely a good thing. As I fire the pump back on, the pool heater automatically turns back on. I come back the next morning and the pool heater is long since idle, having achieved its temperature sitting around 88, 89 degrees Fahrenheit, working just fine. We can see it's just off and sitting there waiting for a temperature sensor to trigger it to run again. And that concludes this video on the repair, maintenance, and inspection of this Pentair Ultratemp pool heater. I hope you found this video enjoyable, entertaining, and informative. Do me a favor, hit that like button down below, helps me out a lot when you do, and hit that subscribe button for more videos like this when they come out. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?